Welcome to our video on Linux security internals. We will cover critical Linux security topics, including permissions, SSH attacks, cron jobs, systemd persistence, and audit logging. This is essential knowledge for blue team professionals. Linux dominates the infrastructure layer, hosting sensitive data and critical cloud workloads that attackers pursue. This includes cloud and servers, containers like Docker and Kubernetes, and high-value targets such as databases and web application backends. Linux permissions are a foundational security mechanism, controlled for owners, groups, and others. Permissions include read, write, and execute. Attackers exploit weak permissions, misconfigured files, and exposed credentials, making permission management a top security priority. SSH provides remote administrative access, making it a high-value target for attackers. SSH attacks include brute force and credential stuffing, using stolen keys and exploiting weak configurations. Blue teams must monitor failed login attempts and unusual authentication patterns. Cron is Linux's task scheduler, used legitimately for automation. Attackers exploit cron jobs for persistence, blending malicious activity into normal operations. Since cron jobs are expected behavior, regular review of cron tabs is crucial for detecting scheduled malicious tasks. Systemd is the modern init system controlling services and startup processes. Attackers abuse systemd to establish boot-level persistence through fake services, modified services, or startup abuse. This allows execution automatically on every system boot. Proper logging is vital for threat detection and investigation. Linux audit tools provide necessary visibility. Key tools include syslog for centralized event logging, journalctl for filtering systemd logs, and audittd for kernel-level auditing of file access and authentication. After gaining initial access, attackers aim to escalate privileges for deeper control. Common privilege escalation vectors include weak pseudo configurations, vulnerable services, and kernel exploits. Defense priority is to enforce least privilege and audit pseudo configurations regularly. Linux security is integral to modern enterprise defense, spanning cloud, container, and DevSecOps operations. SOC analysts must investigate Linux activity across the stack, focusing on securing containers, threat hunting using logs, and integrating visibility into CI/CD pipelines. Key takeaways include enforcing least privilege and auditing permissions. Monitor SSH anomalies, review cron and systemd for persistence, and deploy robust audit logging. Up next, we will discuss endpoint detection and response technologies.